Hello everyone, my name is Madhushri and I'm here with my team to present our project Underage Alcohol Drinking Prediction as part of the Big Data course. We are a team of four, including myself, Elaine, Diana, and Christina. The dataset we are using contains 34,000 records. Each record represents the data of a high school student. The goal of this data is to predict underage drinking by the high school students, which means that we will predict whether the student will drink alcohol or not. That is the column ALC from the dataset with binary values 1 and 0, where 1 being yes and 0 being no. This is an important prediction task for detecting underage drinking and deploying intervention techniques. Now, let us look at the data flow. We import the data and pre-process it. In data pre-processing, we check for the missing values and fill in the missing values. In the pre-processing, we also change the data type of gender into gender index as int. In feature selection, we select the features that are essential for building the model. We then split the data into training and testing in 7:3 ratio, after which we build the models. We check for accuracy in model evaluation and then perform the analysis. We have also visualized some of the variables to see if there is a high correlation along with graphical presentation and box plots. As mentioned before, our dataset has 34,000 records and 13 columns. This slide displays all 13 columns. Let us now go over each variable's description. The absences stands for the number of school absences ranging from 0 to 93. Age is the student's age. Failures are number of past class failures. FAMREL is the quality of family relationships ranging from 1 to 5, with 1 being very bad and 5 being excellent. FEDU is father's level of education ranging from 0 to 4, with 0 as none, 1 as primary education until 4th grade, 2 as 5th to 9th grade, 3 as secondary education, and 4 as higher education. Free time in free time after school ranging from 1 to 5, with 1 being very low and 5 being very high. Go out is going out with friends ranging from 1 to 5, with 1 being very low and 5 being very high. Health is the current health status ranging from 1 to 5, with 1 being very bad and 5 being very good. Medu is mother's level of education ranging from 0 to 4. Gender is the gender of the student. Study time is the weekly study time. Travel time is home to school travel time. ALC is the weekend alcohol consumption. Here is the feature selection step that we have included in the code. The models will be now explained by my friend Christina.
Thank you, Madi. After some thought, we have decided to do three models on our alcohol consumption by high school students dataset. Considering our target value is binary, we started with logistic regression because it is a popular method to predict the categorical response. For that, we needed to import logistic regression from PySpark ML library, which is a machine learning library. In the prior steps of cleaning and preparing the data, we had the column gender transformed from categorical to a numeric value by indexing it. This was a necessary step so that we can train our model. Our dataset was split in training and test 70-30. We did not have to set up to use binomial logistic regression, as Spark was able to infer the correct variant on its own. After fitting the model, we ended up with 81.96% accuracy. Next, we check the area under ROC or the AUC, and we got an excellent value of 0.91. Precision per class was very similar, with non-drinkers at 83% and drinkers at 81%. In the next step, we visualize the predictions. Referring to the confusion matrix, we can see that the model has a decent performance, but there is also an opportunity to do better. The second model we decided to run is k-means clustering, which is an unsupervised learning technique. We're trying to find groups of similar objects within our data. By identifying those patterns, we hope to build a good model. PySpark uses the concepts of data parallelism or result parallelism when performing the k-means clustering. What data parallelism does is creates parallelism from the beginning by partitioning the dataset into smaller partitions. On the other hand, result parallelism is based on targeted clusters. We have used seed 21 throughout our models. The numbers of clusters we did was 2 as it gave us best results. The performance of this model gets evaluated by the silhouette distance, in our case, of 0.73. We have visualized the cluster centers for review on this slide. Our last model is decision tree classifier, which is one of the easiest and popular classification algorithms to understand and interpret. It is a part of the supervised learning algorithms. Unlike other supervised learning algorithms, the decision tree algorithm can be used for solving regression and classification problems as well. Ours is a categorical variable decision tree. For it, we have the default of Gini index, which can be described as a cost function used to evaluate splits in the dataset. It is calculating but subtracting the sum of the squared probabilities of each class from 1. It favors larger partitions and it is easy to implement, whereas information gain favors smaller partitions with distinct values. We realize that each time we change the seed, our AUC changes as well, and the seed at 21 gave us the best AUC at 0.79. In the next step, we will go over our Python code on Databricks.
In command 2, we can see that we have imported the CSV data file, and then we have imported the libraries used to build the models. In command 9, there is a correlation graph that has x-axis and y-axis with ALC, age, febrile, study time, and health. In command 2 is the plot for ALC versus count. In command 14, there is a box plot for age, ALC versus age with hue as gender. In command 15, we can see the feature selection and also the gender index classification. Here in the pre-processing step, we have transferred the gender into gender index as mentioned before. In command 19 is the feature selection code, where we have used vector assembler to select the features essential for building the model. In command 22, we split the data set into training and testing in 7:3 ratio.
In the next few rows, we are running the free models that we have decided upon. First, we start with importing the libraries for logistic regression. Then we run the accuracy and the area under ROC. If we scroll down, we can see that we have also visualized the predictions, and then we have visualized the confusion matrix. In the next few lines of code, we're running unsupervised learning k-means clustering. For that, again, we first import our libraries that are needed, and then it's pretty simple to run all the models after we've already done the data preparation. And then we end with running the decision tree classifier. Again, we first import the libraries and then we run the code for the model. With this, we conclude our presentation. Thank you for watching.